Okay, today I'm going to show you a couple things here that I did to this unit in Madison. Um, this radio is a complete hack job, and it's going to take considerable time, and I haven't even got to the hacking yet on it. But anyway, when I popped this thing open and saw that everything had been replaced in it, and when I say everything, the filter cap, the bridge rectifier, the pass transistor, the driver transistor for the pass transistor, the voltage regulator, the audio amp, another transistor that I'm not sure of just yet. I didn't get there, but looks like another TO92 down there was replaced. Just a whole bunch of stuff. And when you see that, that's just a really scary thing. And it usually means one of three things or a combination of more than one thing going on. But anyway, to get to my point, um, with all that damage to the radio, it just really makes sense to have some sort of overvoltage protection in here. And I don't want to spend an extreme amount of time on this, but what I did to make this a better thing to do, I'm just trying to think of how to phrase this. In order to facilitate the overvoltage, I put an additional fuse holder um, on the output of the power supply. And this is a whole long drawn out story, but somebody switched the fuse holder into a different position. I'm not even going to go down that road. So you'll see I popped an extra fuse holder in here that's just on the power supply itself. It comes right off the emitter of the pass transistor. So it's the very first point on the power supply where you see 13.6 volts. And then I switched this back onto the AC line. You can certainly do this without adding another fuse holder to it. If you hit your line fuse at the right value, I don't think you would have any issues at all, but I do things a little bit differently, so I installed this extra fuse holder. Um, Looking here on the back, this was sitting on there, this little three-terminal strip. So I took that three-terminal strip off. These RF chokes were feeding power from our DC power cord connector um, onto this little terminal strip. So I took these RF chokes off of there and just mounted a 4-bay barrier down here because I needed an extra connection point um, to get on what I needed to get on there. So this just simply didn't work. So there was a bypass capacitor, probably like an 047 or something. You can see setting under this fiberglass tubing that was strapped to chassis ground with a sheet metal screw. So I just went ahead, drilled out the chassis, and put a 440 machine screw in there and some tooth washers and stuff. Now, since I can't see what I see and see what the camera sees at the same time, I'm going to have to put this camera down here because nothing else really works for me. So you can see I just tacked this 4-bay barrier strip in there, just screwed it up into the chassis, countersunk some holes, put some stainless steel screws in, and then I needed to find approximately a 15 or a 16 volt Zener to clamp across that power supply line. I didn't have exactly what I needed, so I seriesed two 7.5 volt 5-watt Zeners inside this tubing. Could have also used a 1N 5352 or a 1N 5353, which would have been 15 or 16 volts. But when you series these two 7.5s together, that's what you get is 15. So I just used them. I also stood the bottom of the Zeners up with another diode to ground. So actually it's 15.6 volts. Is going to be approximately the point of conduction and the voltage that it will start to clamp at. Basically, there's no way for the power supply to rail to 24 volts and damage the radio anymore, because as soon as it does, for whatever reason, these Zener diodes are going to clamp. They'll short within, a fraction of seconds or fraction of a second. They will end up shorting, and once they short out the voltage potential across the main board. So without any voltage potential, there's no damage, no way it can damage anything. And that's exactly what happened in the beginning, at least with the voltage regulator and probably the audio chip, both failing. Were probably over voltage. That little MB voltage regulator setting up here, I think he only handles 18 volts max. That's his absolute max before something bad happens. So with this voltage clamp across there, the unit's safe. It just makes sense if you're going to buy something to try to preserve it. Go through it and look for any weak points that you can find, and doctor it up so it lives to be a ripe old age. So like I said, I did stick another fuse holder in here. It probably would have been fine just working off the line fuse. I'm just guessing probably somewhere around an amp, maybe an amp and a quarter, amp and a half on this line fuse, and that's just a guess off the top of my head. Would have been all right, but the power supply itself should be fused at probably about 4 amps, where it comes off the emitter of the pass transistor. So that's what I got in there. That worked out pretty well. The voltage zings up, the diodes conduct, and that'll stop that problem from happening. Now there was one other thing too. On the back of this, they got the infamous idiot diode back here in case somebody, for whatever reason, flips the wires on the DC power cord input. If they go to wire it up and I don't know, it happens all the time. They wire it up backwards, the idiot diode will short and blow. But the way it was wired originally was really a bad way to do it, because they had the idiot diode on the other side of the RF chokes. So, idiot diodes usually blow open and char and burn apart. But in the process, the amount of time that it takes that diode to do that, usually these RF chokes will torch themselves a little bit. So in order to safeguard the RF chokes, it makes much better sense to put the idiot diode at the power cord. That way there's no current going through the chokes when it shorts. And this here power supply mod with putting the pass transistors on the back on a heat sink was just a wonderful thing. It solved so many problems with it overheating. It can run pretty much 24/7, and it barely gets above room temperature. There was one other modification that I made here, and I'm not sure if I dare to go down this road for fear of what I might say, but I'm going to try to tiptoe my way around the situation. So keep that in mind. So, undoubtedly this power switch had some stress on it when all that went bad, because everything's flowing through this power switch, which one transmits roughly about 2.5, 3 amps. Probably running like 200 milliamps, just the board current itself, plus the lighting current, which is like 400 milliamps now. So it just made sense to me to try to get this power switch to last as many years as possible without having to look for another replacement. So I did this. I just took a good old-fashioned American Zettler relay and stuck it on a piece of FR4 board, a piece of vector board, and wired it right into the power switch. So the power comes right off the power supply at 13.6 and jumps through single pole, single throw contact and goes over and powers up the board into the harness there. And then there's a clamping diode here just across the relay coil. And the coil is actually like about 730 ohms or so, which at 13.6 is probably somewhere around 15 or 20 milliamps of current, if even that. So it takes a very small amount of current to pull this relay on. It's rated at 10 amps. I actually cut one of these apart just to make sure that it was good enough relay, because sometimes you just don't know what you buy, and you got to buy one to destroy it, to figure out if it's any good, to know if you want to buy another one. So that's that's my method of thinking, but it turned out to have really nice contacts on it for the price I paid for it, long story short. So it went on the board. So when I put the power on now, um, the relay just acts as a switch. It's pretty simple. So that's pretty much about all I can really say at this point. It's a very hacked up radio, and it's going to take me a long time to go through this piece by piece. Um, just one thing here I might want to say, and I got to be careful. I got to tiptoe my way around. Make sure I don't head down a bad path here when I start to talk about this. But when you get a radio that's all hacked up like this, it's generally not a good idea if you're going to go in and start to work on it like I am here. You want to be very careful about what you work on. But more to the point, you don't want to clean down your work when you're doing a board like this, because there's been probably, I'm estimating at least 6, if not more, wires pulled out of this board. There's components missing. There's things that were cut. They just did a total hack job on this. So when you clean down the board, basically what that does is it wipes the board clean. So you can't see where all the idiots were with the soldering iron, soldering stuff like I can right here. I can tell that there was a wire originally going to that just by looking at it. Now, if I had cleaned it down, the flux wouldn't be there and the scrapings of the flux wouldn't be there. So it wouldn't be as noticeable to me. So that's kind of what I'm banking on to fix this unit, because I just don't have real good information on it. And I'm a fly by the seat of my pants person. I do a lot of what I do basically just out of my head. That's pretty much how I operate. I've worked on these for quite a while, but sometimes quite a while isn't long enough. So up here, I can see that obviously these have been replaced. Probably the camera can't see it so well, but I can see it. I can see that's been replaced recently. So you don't want to clean stuff like that down. Over here, there's 2 resistors that are soldered across the back of the board. I would pretty much bet a week's wages that the factory didn't install them there. I can tell from the solder joints that somebody tacked them there. So that's kind of a red flag to me. I can see that this guy's been messed with. And I could just go on with this. But I think you get my point by now. So I just wanted to throw that in. Hey, I appreciate you watching very much. Have yourself a great day.